Welcome to today's demo session from Introspect Technology. We're here to talk about PCI Express testing, both from a physical layer perspective as well as from a protocol layer perspective. So the setup we have here today is shown on the right-hand side of the screen. And the first thing to note is how compact this entire bench looks like. This is the entire bench for evaluating multiple channels of high-performance PCI Express links on high-end devices. The portion on the left here where I'm pointing with my mouse is the Introspect SV1C personal SerDes tester, and it's capable of performing PCI Express testing across 8 lanes simultaneously. The SV1C is connected to an ASIC here, a high-performance GPU sitting on a carrier board and attached to the compliance baseboard from PCI SIG. So this is a typical device environment for PCI Express testing. And what we have done here is simply connected the device receivers through 16 wires, basically, to the pattern generator output of the SV1C across 8 lanes differentially. And similarly, we have connected the 8 differential transmitters out of the device under test to the pattern detector inputs of the SV1C. And finally, we've attached the clock injection port of the SV1C to the CBB clock injection input, and this constitutes the entire setup basically for PCI Express testing. One of the first things that we have to do when it comes to PCI Express multi-channel testing is to negotiate with the device and understand its capabilities. And so to do this, we look at the Introspect ESP software on the left-hand side here, where we have developed automation suites basically to enable just that. And what these do is they verify the outputs of the device, perform some kind of training sequence training on the device so that we could understand its capabilities. And so we'll go ahead and do that and see what happens. So click Run. This is a pre-configured automation script that we have basically written, and that's available with the Introspect ESP software. And the script right now is running by virtue of this blinking light on the bottom left here, and also by virtue of the log messages that are coming out. And what the SV1C is doing really is it's sending training patterns, it's receiving training patterns from the device to determine things like loopback capability or whether the device is able to toggle from Gen 1 to Gen 2 and Gen 3 and so on. And so it's doing this right now as a quick diagnostic tool, and within seconds, as we see here, we're basically able to complete the entire analysis of the capability of the device. So we're seeing that we have 8 lanes that are active on the device, which is what we expect, and that the device is able to toggle to Gen 2 and is able to perform loopback training, which is critical for receiver testing. So this is a device identification step basically that takes seconds, but within seconds we're able to determine the capability of all lanes. And in the process, the tool has also given us some captures of waveforms that have been received. So this is an example of a waveform that's been received. This happens to be a comma character that was used in loopback training. And then we can look at some other waveforms. These are compliance patterns basically out of the PCI Express device, which are again 8-bit, 10-bit encoded patterns with some comma characters interspersed throughout. And so this was a quick demo of the hardware setup and the software setup that enables us to negotiate the capability of a PCI Express device and determine whether it's able to toggle to various generations of speed and whether it's able to enter into loopback for the purpose of receiver testing. Thank you.